is named as a diamine, and 4 acetic acid groups is named as tetraacetic acid. So that's why it is called EDTA. It is a ligand, or ligand means nothing but it is we discussed in the complex compounds or coordination compounds. That means any substance that can able to donate electron pairs to the metal atom and forms a complex compound. So that's why this method is also named as complexometric method. So why it is named as complexometric? Because this EDTA ligand will donate the electron pairs to the metal atom. Where the metal atoms? Metal atoms are dissolved in the water, like calcium and magnesium. And this, when the EDTA solution added to this metal atoms, and they can form a complex compound or coordination compound, and that's why the name came from that concept, complexometric method, right? So when the EDTA reacts with the metal ions, it can form a metal EDTA complex. It can form a metal EDTA complex, and hence it is also called as complexometric method, right? So as we discussed, and what the principle involved in this method, and what is the process we discussed for the estimation of hardness of water. The simple principle is there that EDTA is a good ligand, and metal ions like calcium and magnesium ions, which causes hardness to the water, present in water, and they react to each other, or they react forms a complex compound. And in this principle, the metal and EDTA ligand, a complex structure will also be drawn. That is, so this is a complex compound will be formed, that is metal EDTA complex. Metal EDTA complex, and here in this complex formation we use disodium EDTA ligand, that is disodium salt of EDTA ligand, and it forms a 4 coordinated bonds with the metal atom. M refers to the or different metal. It may be M is equal to calcium Ca plus 2 or magnesium plus 2 ions. So how the reaction takes place? First, for this process there are few steps involved in this analysis method. So that is preparation of EDTA solvent and preparation of buffer solution. Here for chemical reagents or chemical solvents we use. And first, when this metal react with the EBT indicator, and the EBT metal complex will be formed initially, and this metal EBT complex is somewhat less stable. And when we add EDTA solution to this mixture, and this metal EBT complex is dissociates, and then it can form metal EDTA complex. Why? Because EDTA ligand is good electron donating ligand or powerful complex formation ligand. That's why metal EBT complex dissociates and metal EDTA complex will be formed. So that is first reaction. If M plus 2 ions when react with EBT indicator, in this titration method we use EBT indicator, that is 2, which is useful for the identification of end point or equivalent point by the color change. And the metal EBT complex is formed, and which is wine red color, and this metal EBT complex further when react with EDTA, and this is in the presence of pH level 10, that we use buffer solution to maintain pH 10, and the metal EBT complex when react with EDTA, then it can form metal EDTA complex, and it gives free EBT, and this is in blue color, so that we can identify the change of the solution color from wine red to blue color indicates the end point of the reaction, right? So by this distinguish, for this purpose we use a EBT indicator, and it efficiently works at pH 10, right? And in this way we estimate the hardness of water by EDTA complexometric method or EDTA method, right? And by calculating its values from burette reading, as we add EDTA solution from the burette, and then we calculate V1, V2, V3, and from that values or EDTA volumes we estimate the total hardness, temporary hardness, and permanent hardness present in the given hot water sample. Okay, thank you.